chapter 10, still dealing with inequalities, and this is 10.2, section 10.2, solving inequalities. So we see that we have comparisons for all real numbers a and b. One and only one of the following statements is true. Either a is less than b, a is equal to b, or a is greater than b. So those are three what we might want to call states. So those are the three states that two numbers can have. One can be less, one can be greater than, or it must be equal to. The transitive property. If a is less than b and b is less than c, then a is less than c. Right? Because meaning if a is less than b and c is greater than b is the better way to look at it. So if c is greater than b and a is less than b, then a must be less than c. That's a really good transitive property. So if c is greater than b and a is less than b, then c is greater than a. Same thing, it's just inverted. Addition property, if we have a that is less than b and if we add the same number to both of them, then the sum of a and c still must be less than the sum of b and c. That makes sense, right? And so same goes into case if a is initially larger than b and we add the same number to a and b, a plus c will still be larger than b plus c. Multiplication property of order, same thing goes for multiplication. That's not going to change anything. Even if we make c is greater than 0, if it's negative, then it's going to be reversed. So that's the fun thing is if a number is bigger than another number and you multiply it by a negative, then it's going to be even bigger but smaller because it's going to stretch on the other side of this axis. So if we take this situation, this is how I see it, you know, if this is 0, this is b, this is a, and we put a multiplier of something, if we multiply it by 3, it's going to extend 3 times further that way. And if we make it negative 3, that means if we do the opposite of that, if we multiply it by negative 3, then it's going to stretch it further that way. So remember, the negative sign is just direction. Our number is going to have distance. That's an important thing for people to continue. I always teach this quite often, is that every number, I don't want it in red, every number, very interesting concept to think about. If you take a number like 6, negative 8, 3/4, negative 2.7, every number has a direction and a distance. Every number has direction and distance other than 0. 0 just doesn't have a direction, and technically I guess it doesn't have a distance either. So the direction is positive, so that's to the right, and it's 6 units. Negative 8 is to the left, and that's 8 units. That's the distance. 3/4 is to the right, and the distance is 3/4, and negative 2.7 is to the left, and it's 2.7. So if we go back to this example, if we take a and expand it, or proportional, we extend it 3. If we do it negative 3, we're still expanding it 3. We're just expanding it in a different direction. So a will be further out, negative a, and negative b. Negative a will be further away, so it'll be smaller because we go smaller to bigger on a number line. So I don't know. That's just something fun. Thought I'd start that video out. We have vocabulary equivalent, inequalities, transformations that produce an equivalent, substituting, adding, multiplying, dividing. So we know that Multiplying both sides of an inequality by 0 does not produce an inequality. The result is the identity 0 equals 0. So there are some more fun things that we're going to learn here, especially multiplying by negative. Tell how to transform the first. So what do we do to go from this statement to this statement? What's missing? A negative 6. Well, how do we get rid of a negative 6? We add 6, and if we're going to do it to one side, we're going to do it to the other. So that leaves us with m. The 6 and negative 6 cancel. You're left with the variable is greater than, and because we added 6 to 2, we got 8. What happens here, and let's look at this. Here's the next lecture for us today. So there are two ways to get this to be, let's do this. Let's just do negative k. Let's do this. This is a lot easier. Let's do negative k is greater than or equal to 4. There are two ways that we can make this variable positive. We're solve for k, and to solve for k, one of the ways is, hey, why don't we add k to both sides? We would get x is greater than or x 0 is greater than or equal to k plus 4. Then we can subtract the 4 over, and we get negative 4 is greater than or equal to k, or k is less than or equal to negative 4. If we write the variable first, we notice it's eating the negative 4. When we rewrite it, we get k is less than or equal to negative 4. So notice that in order to make our k positive, when we move it across the equal sign or the inequality, we make it positive. It's on the left side. When we move it to the right side, we change its sign. That's going to be the case for anything. If you have negative 3x equals 10, if we add 3x, it now becomes positive 3x. So when we moved it across the equal sign, we changed its sign. If we did it the other way, if you had 16 equals 5m, if we subtract 5m, if we move it across the equal sign, notice it went from positive, we moved it across to negative. So whenever we change the sign of a coefficient, all we're doing is really moving it across the equal sign. And if we move it across the equal sign, we know that we're going to change its sign. So if we want to change this sign of the coefficient, we just move it across the equal sign. And that works for inequalities also. So what am I working at here? Okay, so we see that if we move this negative k to the other side, it becomes positive. Now, when it's an equal sign, it's okay, because an equal is a balanced equation. It's balanced on that fulcrum. Left side is equal to the right side. Okay, this side is always going to be equal. In an inequality, though, that changes things. We know the left side is more than the right side. So notice that when we moved it, we took our variable that was greater, and now our variable or our solutions are less than. Wow, so that's kind of important, that if we move it across, we're going to change the inequality. So we are physically moving our variable over when we add k. We see this rule that, hey, when we multiply both sides by a negative, it turns it to a positive. And we are told that we have to flip the inequality. We have to flip the inequality because we just turned it from a negative to a positive. And remember, when we turn something from a negative to positive, we changed the side of the inequality. It was greater than, now it's less than. So we changed it from greater than to less than. But notice our variable stayed on the left side. So instead of moving it physically, we can change it from negative to positive, keep it on its side, and we did the flipping by physically flipping the inequality sign. So that's what's going on. I don't know how many teachers are able to explain that, but that's why when we multiply both sides by a negative, we have to flip the inequality because we are representing the movement across the inequality. A little FYI, important. Some of you will get that ideology. Some of you will need a little bit more time to, as we say, marinate with that. But it's an important understanding of why. Don't just do it to do it. Understand why we do it. Very important. So tell how to transform the first inequality to the second one. So what are we doing to the left side to make it t? Or what are we doing to the right side to make it 4? So we have to subtract 2 from both sides. From both sides. What are we doing? We are adding 3. Add 3 to both sides. So maybe not from, to. -2, add -2, subtract 2 to both sides. Add 3 to both sides. Don't know how your wording is going to be, but what are we doing? We are subtracting 5 from both sides. Observing, understanding, how do we isolate, how do we get x by itself? We're going to subtract 5. Tell how to transform the first inequality into the second one. What are we going to do? We're going to multiply it. So what gets rid of a 4? Well, that 4 is being multiplied. So we can't subtract 4 because 4p and subtracting 4, those are unlike. So that doesn't work. No. We can't, what's another thing? I don't know how else, minus p? Yes, that's another one that students do. Oh no, yeah, no, minus 4. Well, minus 4, minus 4p, minus 3p. Ooh, that would be good. Minus 3p, because that would get us p. That definitely gets us p, but if we subtract 3p from both sides, that p just gets over here, and that statement becomes p is less than 28 minus 3p. So we didn't actually make it. We had one variable. Now we definitely have p, but our right side is not 7. It's 28 minus 3p. So that didn't work. So what adding and subtracting isn't going to get us to p. Okay, 4p to p. We have to get rid of that 4. That 4 is multiplying. That 4 is multiplying p. So what is the inverse of multiplying 4? The inverse is dividing by 4. So there are two things. We can divide by, no, I don't want red. One option is divide by both sides. Both sides by 4. So if we divide 4p by 4, we definitely get p. If we divide 28 by 4, we definitely get 7. So that's one. Here's the other one. Not only will dividing, multiplication, the inverse of multiplication is definitely dividing, it also is multiplying by the reciprocal. Multiply both sides by 1/4, because 4 times 1/4 also gives us 1. Any number multiplied by its reciprocal will give us 1. And 28 times 1/4 will also give us 7. So that's a nice way. I would always accept either. So we can either divide both sides by 2, or we can multiply both sides by 1/2. Not negative 1/2. Negative, that's not an inverse. The inverse of multiplication does not involve negative. Just includes that number. We're going to divide it by that number. That's a mistake that students will also make. So here's our negative. So we can either divide both sides by -7. The inverse of multiplying by -7 is dividing by -7. And then it is also, the inverse is also multiply both sides by -1/7. That would be the reciprocal. And when we multiply both sides, we would flip the inequality because we are representing that movement across the inequality. It would be on the greater than side now. This is good. So when we're dividing, the inverse of dividing is multiplying. Multiply both sides by 5. So the inverse of division is multiplication. Multiplying both sides by 5. 5 in the numerator gets rid of the 5 in the denominator. It leaves us with x. Multiplying 3 times 5 gives us 15. We are going to multiply both sides. Nope. Both sides by -2. Multiplying both sides. What gets rid of a -2 in the denominator? A -2 in the numerator. And we'd multiply that -2 in the numerator by -4, which makes +8. And we would flip the inequality because we took a variable that was negative and made it positive. So that was the interesting thing. We are going to multiply both sides by -3. Let's do another one. What would you do here? What if you had -5/3 x is greater than 2? What would you do? You'd multiply both sides by -3/5. Woohoo! So, and this could look like this too. These are equivalent inequalities. -5's in the numerator, -5's in the numerator. X is in the numerator, x is in the numerator. 3 is in the denominator, 3 is in the denominator. So instead of doing it in 2 steps, the 2 steps would be multiply by 3, and the other one would be divide by -5. Well, multiplying by 3 and dividing by -5 is the same as multiplying by 3 and dividing by 5, or multiplying by -3/5. So nice little one there. So here they want you to isolate the variable and then graph its solutions. Interesting about this is that we have variables on both sides and constants on both sides. We're always going to move the variables first. No. Oh, that's interesting. They did not. They moved the constant first. I would tell you not to do that. There will be problems that you will struggle with. Can you do it? Yes. Is it the best way? No. I always tell students to move the variables first. Here we have to simplify. Simplify through distribution. We're going to distribute, and then we are going to isolate. We will move the variables. You can move the variables and the constants at the same time. I'm okay with that, but we're always going to move, when we have variables on both sides, I'm always going to move the variables first. And we get this situation. So x minus 2 is greater than or equal to 3. What's happening to the variable? 2 is being subtracted from x. The inverse of subtracting 2 is adding 2. So we're going to add 2 to both sides. A -2 and a +2 will cancel, leave us with our variable is greater than or equal to 3 plus 2, which is 5. And I'm going to have to move every single one of those graphs up. This is how Mr. Mac graphs. He finds 0, shows where 0 is. He shows where his solution is. Open or closed, it's going to be a closed circle. And greater than or less than, it says x is greater than. We always think of x as the solutions. The solutions are greater than 5. So tell me where the solutions are greater than 5. That would be in that direction. I always do my graph above, because if you do it down on the graph, well, let's connect those. First of all, group. If we do it on there, it's kind of hard. It gets noisy there. I don't necessarily know exactly where it is. So I ask students to put the graph above the number line. And you don't need to do all these dashes because that's noisy also. There's no need to know how many dashes. Just tell me which side of 0 it is on. Show me where 0 is. Show me where your solution is. And then graph the important information. So Mr. McDougal has some particulars about how he likes to get it done, how he likes to see it done. So what is the inverse of adding 2? Would be subtracting 2. We get 6 is less than or equal to z. Now, a lot of students will go 0 and 6. It's going to be an open circle. Let's talk about that. When you have less than or equal to or greater than or equal to, we're going to have a closed circle because that means including, because it's less than or equal to or greater than or equal to, so we're including, it's going to be a closed circle. We call that a closed circle. When we have less than or if we have greater than, it's going to be an open circle. That means not including. And that is an open circle, meaning it's not true. It's not a solution. This is a solution. This is not a solution. So it says open circle. Now here's the tricky part. A lot of students will look at this. Notice the variable, the solutions are after. So it says 6 is less than the solutions. Well, that's hard to understand. So I would much rather you rewrite this. When we look at it, is the inequality eating the solutions or the 6? It's eating the solutions. So when I rewrite with my solution first, notice it's still eating my solution. So now it's the solutions are greater than 6. That's easier. Now I know what's going on. So my solutions are going to be there. Notice 6 has an open circle because I'm not going to include that. If I plug 6 in, 6 plus 2 is not greater than 8. It's actually equal to 8. So 8 is not greater than 8. So that would be a false 7. If we put 7 in there, 7 plus 2 is 9. 9 is greater. So notice all of my solutions are here. These are true values. If you plug this point in, it makes the equation or the inequality true. If we plug in this, it's a false because it's open. That would produce a false statement. And these are not graphs, so they're not solutions. So these would also be false. This is a boundary between the trues and the falses. Do we include the boundary? No, we do not. So let's divide by 4. Inverse of multiplying by 4 is dividing by 4. So we get p is less than 5. We have this silly graph that I put too low. 0, 5. Open or close is going to be open. Going, my solutions are less than, so my solutions are less than 5. If you use this technique, it will be very, very easy for you to get all these problems right. Divide by 5, divide by 5. 3 is less than or equal to w. I'm going to rewrite it. It's eating my variable, so when I rewrite it, it's still eating the variable. I'm going to find out where 0 is. I'm going to place where my solution, where my boundary is, and then it is an equal, so we're going to close the circle, and my solutions are greater than 3. So I'm going to go to that direction. I'm going to divide by -6, divide by -6. Because I'm changing a variable from negative to positive, I must flip the inequality sign. I'm keeping it on the right side. Remember, in order to make something positive or negative, you have to move it across. Since I didn't move, I'm showing the act of moving by flipping the inequality sign from a greater than to a less than sign. And then -24 divided by 6 is 4. So there is my solution. Now I'm just going to rewrite it with my solution first. I'm not flipping the inequality sign again. I know I moved it across, but I moved everything. I just rewrote this in a different format. So don't misinterpret flipping here with flipping here. I know that's kind of confusing, but we are going to expect that you can comprehend what we're talking about. Open or close doesn't have an equal sign, so it's open. My solutions are greater than 4, so I'm going to draw an arrow to the right. We are going to, what's the inverse of dividing is multiplying by 2. So D is greater than, we didn't change the sign, it was positive, it's still positive, is greater than -6. But you got a negative. No, we didn't multiply both sides by a negative. We multiplied both sides by a positive, so we do not flip the inequality sign. We didn't move it across the inequality. So we have 0, we have -6 is going to be on the left side of 0. It's an open circle and values that are greater than -6. Let's move this. Wish I could go to all of them and move them. Oh, somebody just called. Campbell just called. Oh, this is a good one. So we can do 2 ways here, lots of ways. I got to get my G positive, so I'm going to move my G. Notice that it went from greater than to less than over on this side. So notice my solutions are less than 3. That's one way of doing this. You could have done it in a little bit more time consuming. We can get rid of the 3. You have negative G is greater than -3. And now I need to change my variable. It's being multiplied by -1. The inverse of multiplying by -1 is multiplying by 1. But I have to flip the inequality sign because I multiplied both sides by a negative. So I have to flip the inequality, and we get G is less than 3. Which step is easier? This step's easier. 0, 3, open circle, less than. So these are good ones. Let me just text. I'll call you in a sec. And I didn't mean to hit that. That's good. Perfect. We got it. Open circle. That is correct. 2-step equations. Okay. That's not hard. Let's do it. Let's get rid of the things being added and subtracted first. We only have one variable, so it's okay. And then we're going to do the inverse of multiplication, which is division. We get V is greater than 4. Show me where 0 is. Show me where 4 is. Open circle, because it's not including. And my solutions are greater than 4. Good. What's happening to the variable? 2 things are happening to the variable. It's being multiplied by 2, and 6 is being subtracted. We get rid of things being added and subtracted first. That gives us 12 is greater than or equal to 2k. 2 is multiplying, so the inverse is divide by 2. So we get 6 is greater than or equal to my solutions. I always like to write my solutions first, my variable first. It's eating the 6, so when I rewrite it, and now I'm going to graph it. So I show where 0 is. I show where my solution is. It is a closed circle because I'm including the solution or the boundary. And I need, my solutions are less than, so I'm going to go to the left. Ooh, this is good. So let's move my little arrow, my number line here. So being divided by 2, being added to 3, I'm going to do the inverse of adding first. I get x over 2 is less than or equal to 1. I'm going to do the inverse of dividing by 2, which is multiplying by 2. X is less than or equal to 2. Why didn't I flip it? Because I didn't multiply it by a negative number. So 0, 2, it's going to be a closed circle. My solutions are less than 2. Hopefully you're getting this, and this is becoming more clear through this repetition and practice. This is chapter 10. You should know most of these things by 8th grade in chapter 10. We're going to subtract 6 from both sides. Minus 2/3 c is greater than negative 6. We are not going to divide by negative 2/3. I know, Mr. Mack, it's multiplying by negative 2/3. The inverse of multiplying is dividing. Well, I don't know too many students who want to do this right side. I'll tell you how you can. It's negative 6 divided by negative 2/3, which becomes negative 6 times negative 3/2. When we convert division to multiplication, we take the reciprocal of the right side. Hey, look at this. Instead of dividing by that fraction, remember, multiplication has two inverses. It is division. It is also multiplying by the reciprocal. And look at that, kids. You're going to get there. Look at that. You're multiplying by negative 3/2. So instead of doing that division and getting to this part, just jump to it. Now, any number times its reciprocal is going to give you 1. You're left with the variable. Because I divided both sides by, or multiplied both sides by a negative, I must flip my inequality. I'm going to cross cancel. That becomes 3. So it's negative 3 times negative 3, which is positive 9. So my solution is C is less than 9. 0, 9, open circle, less than 9. So there are a lot of things happening in this problem. If you got 20 right, that's a good sign. That's really, really good. So, oh wow, we got a whole bunch left. Okay. Oh yeah, we are definitely going to test your mettle today. So notice we have variables on both sides. I would always move the variables first. And then I'd move the constants. Negative 5 is less than r, also known as r is greater than negative 5. I have my 0, I have my negative 5, open circle, my solutions are greater than negative 5, values greater to the right, and we just graphed it. Here we're going to move the variables first. We have variables on both sides. We get y is less than 6. Oh, that was nice. That was not a hard one. 0, 6. It's just less than, and there is no equal sign, so we're going to have an open circle. My solutions are less than 6. Values that are less than 6 are to the left. I'll show you another technique here. I know that they want to move the constants first. You are able to do both at the same time. So if I'm moving my variables to the left, I'm going to move my constants to the right. So in high school, you'll see students do this. And we see that the constants cancel, the variables cancel. They consolidate the variables on the left side, which is positive. And then we're left with a consolidation of the constants on the right side. I don't have to flip the inequality because I didn't multiply or divide both sides by a negative. I added and subtracted, but that's not going to affect the inequality. So we're left with f is less than 5. So let's graph that. I write where my 0 is. I show where my solution is. It's an open circle. Values are less than. We again, is that the same problem? Nope, look very similar. I'm going to move my variables. I'm going to move my constants. And I always move my variables so I end up with a positive variable. That's just more efficient. Why end up with a negative variable? And then you're going to have to get rid of that negative sign. And that just leads to places to make silly mistakes. So we have r Our solution is -4, our boundary is -4, and my solutions are going to be open circle and greater than. So it looks like that. Notice this, I'm going to add 2b. That gives me a positive variable. I'm going to minus my constant. Get my constants on the left side is greater than b, or b is less than 3. I'm always going to write my variable first. That's just how I work. Open circle, my solutions are less than. If you do it with your variable first, you can read it and it will tell you which way your solutions go to. If you don't, then you're going to have to do a lot of interpretation. So there's two ways to do this problem. We'll do it first. We'll do it through distribution. We can simplify. Oftentimes, we're going to distribute. So that gives us 2x minus 6 is less than or equal to 4. Add 6, add 6. 2x is less than or equal to 2. Nope, that's 10, sorry. To 10. Divide by 2, divide by 2. X is less than or equal to 5. I'll show you a more efficient way that high school students will do is, hey, I can't get into here to get to my variable yet. So I have this, I have Chewbacca protecting the variable and 2 outside here multiplying Chewbacca. So let's get rid of the 2 that's multiplying. I'm going to divide by 2. Well, dividing by 2 cancels it and sends Chewbacca back home. And 4 divided by 2 is 2. We'll add 3, and we get x is less than or equal to 5. That's the efficient way. This is the way high school students are going to do it. This is how elementary students are going to do it. And that's just a lack of understanding here. They just go through the process and it's sort of rote, so they're not really understanding what they're doing. Here, you're understanding the big picture. You have this quantity and it's being multiplied by 2, and we got to get inside that quantity. So let's get rid of things. One way of getting rid of Chewbacca is by distributing, but that's not really efficient. There's a much more efficient way. So you'll see me do both techniques depending on the group. So I like this technique. It's going to be a closed circle because it's equal to. My solutions are less than 5, so we're going to go there. Same thing here. I'm going to divide by 3. That gives me 2 is less than 2 minus m. I'm going to add m. I'm going to make my variable positive. That's m plus 2 because I added the m to the side. I didn't multiply. It's not 2m. These are unlike terms. So when we add them, we're going to, and then we get 2. We're going to subtract 2. We're left with m is less than 0. We have our solution is 0, open circle, and my solutions are less than. That's a good one. Here, okay, so now you cannot divide by 3 because if we divide by 3, you're going to have to divide everything by 3. And not to say that that isn't bad. I mean, if you can work with fractions, good for you. But not a lot of people are comfortable with fractions. 3x over 3 is x plus 2/3. Oh, look at you. This is not going to be fun. There's a lot of things. So we move the variables, and you get 2 is less than or equal to 2/3. Notice the variables cancel out. Notice. Variables cancel. That's a very unique situation. Variables cancel. And they make a false statement and make a false number statement. 2 is not less than or equal to 2/3. When the variables cancel and they make a false number statement, the answer is no solution. if the variables cancel out and they make a true statement, so now let's not do that. Let's look like an ear right there. Look like Charlie Brown, kind of. Let's do this. If they cancel and make a true statement, then it's all real numbers. So if the variables cancel and you make a true number statement, then the answer is all real numbers. That's something to just understand. The answer here is no solution. There is no values that you can plug in for x to make that statement true. The left side equal, or left side less than or equal to the right side. Let me show you through the distribution if you had that statement. Let's do this. Copy, paste. What? That didn't copy. Copy, paste. Thank you. Let's make it a little bit smaller. So if we do the distributive property, so if you distribute, in order to get rid of the parentheses, you get 3x plus 6 is less than or equal to 3x plus 2. Let's move the variables, and you get 6 is less than or equal to 2, which is still false, which still gives us no solution. So both ways are okay. And just remember, if the variables cancel and they produce a true statement, it's all real numbers. Is that what this problem is going to be? Maybe. Nope. It is not. Let's look at this one. So I wouldn't divide by 4. I would distribute both. So this is one of those situations where it's actually not more efficient to move the constant. So we get 4k minus 12. 4 times k is 4k. 4 times negative 3 is negative 12. It's greater than or equal to 6 minus 6k. 6 times 1 is 6. 6 times negative k is negative 6k. Let's move the variables. Let's move the constants to the other side. We're canceling the constants on the left. We're canceling the variables on the right. That leaves us with 10k is greater than or equal to 18. Wow, they're really going to just make it fun for us. So divide by 10, divide by 10. You cannot leave it as 18 tenths. You must simplify all fractions to 9/5. You don't have to make it a mixed number, but you can't leave it as a unsimplified fraction. So I'm always going to simplify it. I'm not going to turn it to a mixed number. If you turned it to a mixed number, that's okay. So this is the only answer. This must be simplified. Must be simplified. Mr. Mack, this isn't simplified. Yes, it is. There's no number that goes into 9 and 5. Turning it into this 1 and 4/5 is not simplifying. That's not simplifying. That is called converting. That's called converting, not simplifying. Turning it from a mixed number, turning from an improper fraction to a mixed number is called converting. It is not called simplifying. And that's it. Lots of things in this video. This was a very, very beneficial video. There's lots of things, lots of little nuances and peculiarities that you have to be wary of, and you've got to know this. It really makes a huge difference in your algebra, geometry, algebra 2, pre-calc. These are very, very important concepts that need to be learned and are oftentimes just glossed over because kids aren't paying attention. It's glossed over because it's hard to explain. It's hard to remember, but these are very, very important concepts. So hopefully you took that in. Good luck.